Hello students, hope you all are good. Let us do today the new chapter, motion in plane. So in this chapter, we will talk about 2D motion. When we say plane, it is 2D motion. So first of all, try to visualize in your day-to-day life, where do you see what type of motion can be considered as 2D motion. See, if you consider the direction of or the sense of motion of, suppose, car we are taking. In that car, if that car is moving, so that car is moving in a plane. It can go in this direction, it can go in this direction, not in only one line. It is, on the plane, on this plane, suppose this is the plane, on this plane it can go anywhere, right? It can go anywhere. Now visualize, you have to see the direction of the way the way motion of football is considered. That can be considered as 2D. If you have got this, suppose this is the plane, and in this plane you have kicked the football, it goes up like this on this plane, right? This is also 2D motion. But here the plane is considered in this manner. The car is considered, the motion of car is considered in this manner. This is the plane, right? On the road, horizontal road, right? Road is a plane, and on that plane, so we need to visualize this. In this particular chapter, there is focus upon, right? We will understand what is vector. I will give you the chapter review. So we need to, yes, this is the chapter review actually, right? This is the chapter review. Introduction. Then there is a sense of vectors. There is different algebra, vector algebra. Vectors cannot be added the way we add two masses, like two mass of two bodies. Suppose mass of this body, mass of this body, we add them together as this. If this is 2 kg, this is 3 kg, 2 plus 3 is always 5. But when we have vector algebra, 2 plus 3 can be 1 also, 2 plus 3 can be some other value. So 2 plus 3 can be between this 1 to 5. It can take any value between these two, including the two values, right? So vector algebra, that is very exciting. You have to understand how two vectors are added, how two vectors are multiplied, how to get the component of one vector on a different axes, right? So these things are done in vectors. Then there is relative motion. Relative motion. The typical example of relative motion can be, suppose this is airplane going in this direction, right? But wind is blowing in this direction. So what do you think? It will go straight? No. It has some sense of this. It will go in this direction. Can you visualize it? See, mastering concepts of physics, applying it, can be fun if you start visualizing it. If you can't visualize, then things can get boring, things can get difficult, things can get something which you cannot apply quickly. If you start visualizing it, the way I'm telling you that, okay, airplane, imagine, okay, airplane. If it is going in this particular direction straight, it has to go. Now, you can take another example. This is the river, two banks of the river. This is bank A, bank B, right? Here, this is the flow of river. This is the direction of flow of the river. If you wish to cross the river from this point, let's say you have started from here, you will start swimming in this direction, but you will not reach exactly at this point straight, you would not be able to reach here. You will reach, due to this flow of river, you will reach here. You will reach here. So this is the concept of relative velocity, where this vector manipulation comes in. Understood? So this is very exciting stuff. Relative motion. Okay? Now, there is another one. Projectile motion. Projectile. What is projectile? The motion of a football. Motion of cannonball from cannon. If it is fired like this, a football will go from here, right? It goes up and then comes down on this plane. On the horizontal surface, it comes again. It comes due to the, obviously it is under the gravity, it is coming down. You have kicked this in this direction. It goes up, so it travels horizontal direction, travels in the horizontal direction also, and in some vertical direction also. So here the plane can be considered as this plane. It goes up, it comes down. Right? So there is cannonball also fired in that manner. Right? There are multiple projectile motion. Another way, typical example of projectile motion. Suppose, if you have heard about it, airplane. If from airplane something is, right, something is dropped. It is moving in this direction. It is dropped here, but it will reach here. It will reach here. This is the airplane. This is the airplane. From this, if airplane moving in this direction, from this, if some packet, something is dropped, it will not come straight here, it will follow this path. Yes, under the effect of gravity. So this type of motion of object can be considered as projectile motion, right? And this type of objects, bodies, which undergoes this type of motion is called projectile, right? Now there is the next one, uniform circular motion. This is very interesting. This is very interesting. On the horizontal surface, if you have, suppose you have a string and you have tied a pebble on this, right? And you start whirling this. It follows this path, circular path. Circular path, right? So this as the center. Here, speed of this pebble is not changing, but the velocity is changing. That is also a very interesting fact. Direction of this at every point is different, right? Direction of this pebble at every point is different, but the magnitude of the velocity is not changing, speed is not changing. That is why it is called uniform circular motion. This is moving, this pebble is moving in a circular path. At every point, it has got different direction, right? But since magnitude is constant, it is uniform circular motion. And as a matter of fact, uniform circular motion is an accelerated motion, because when we say acceleration, acceleration is change, rate of change in velocity. So any of the two, velocity is a vector, that basic idea we have till now, although we will talk about this in much detail when we will discuss this vector. any of the two is changing, any of the two things for the velocity, magnitude and direction, any of the two is changing, velocity is changing. Velocity is changing, acceleration comes in. So uniform circular motion is also an accelerated motion. These are very simple concepts, basic concepts, basic idea of what is uniform, what is constant, what is changing, okay? And be it board exam, be it NEET or any other exams, something or the other can be asked from this very basic stuff, okay? We'll talk about this in much detail when we will particularly do this uniform circular motion, right? So this was the chapter overview. Now we will move ahead to understand what this vector, what are this vector, how this is so important. I will take example. Till now you have understood the motion in a straight line, motion in a straight line, motion in a straight line. So suppose this is origin, this is the point where the motion of a body is started. So you have taken this, suppose this is x, okay, this is x. When we say plane, when we say 2D motion in a plane, what we are actually saying is it has got x. Suppose this is origin, this is plane, and this is y, right? So this can be considered as this. You can see these are the two axes. These are the two axes. This is a plane, right? This is a plane. In this plane, you are considering the motion. That means now motion in plane, in this particular type of motion, what will happen? We need to look into x and y coordinate also. It's not only this value of x that would matter to us. Here x and y both would matter to us. The change in position along x-axis and along y-axis both will matter. Right? Okay. First of all, position. Talk about the position of a particle. So that position coordinate can be this. Suppose I have a particle, let's say this is the particle here. This is the particle. Right? This is the particle. And the coordinate is 3 and 4. Mind it, this is very simple. Coordinate is 3 and 4. When we say 3 and 4, that means x coordinate is 3, this is 3, y coordinate is 4, y coordinate is 4, this particle is P, right? So first thing that we need to keep in mind, we must have some mechanism, some tool to express the position of this particle in a plane. In a plane. In a plane means it's not only x-axis, it's not only x-axis that would matter, it would be y-axis also. So we have some tool, some mechanism to express the position in terms of x-axis and y-axis. Right? So let us talk about this. Let's call this, suppose x-axis, along x-axis and y-axis, there is a sense of, direction with the tool, say, I cap. For x-axis, this x-axis is represented by I cap. Let's call this. Y-axis is represented by J cap. For the time being, just consider this. Now what will happen? The position of this particle, first of all, take the coordinate. Now talk about the position vector. We say this is position vector. Position. We'll talk about this vector later. First of all, position. Position is expressed, here you were saying this coordinate, just have a look. 3 along what? X-axis. So 3 into I cap. This. So this represents the magnitude and this represents the direction. This is very, very significant here. This is magnitude and this is direction. Magnitude and this is direction. I am not right now in a conventional way, I am not starting this, what is vector? I am not starting with this right now. I am just telling you how significant this direction can be and why this is so significant. Okay? So this vector, now call it a vector. Any quantity, right now what we are actually talking about, we are talking about position. What? We are talking about position of a particle. It is simple, no? You are aware of this, that when you define displacement, you are saying that there is a change in its position, right? So you would say initial position, you would say final position. Ultimately, you are talking about position. First of all, think how position is expressed not only in terms of magnitude, rather there must be some tool to express magnitude as well as direction. You would say, you are aware of this, displacement. When you say displacement, displacement is not like this, that you will simply say that, okay, 5 kilometer. Suppose you are at this position, you know, you are at your home. Suppose you are at your home, right? And you would say that you traveled 5 kilometers. Okay, fine, but 5 kilometers where? In what direction? 5 kilometers along x-axis, 5 kilometers along y-axis, or 5 kilometers along z-axis? Where? So that is very important here. You need to specifically mention in which direction you are moving, or in which direction you have changed your position from home to somewhere else. In what direction? Right? That is important. So this is the way to express the position of this particle. Suppose you are on this plane and right now your position is here. Take some reference point. From this reference point, your position coordinates are 3 and 4. Position coordinates, x coordinate and y coordinate, 3 and 4 respectively. Right? So this is important. Now, from this reference, you just take one shot, one single direction. How far you are from this reference point? What is that distance? Shortest distance, that is displacement, right? We are saying if you are from this reference point at some position, what is that minimum distance? Yes, it would be a straight line joining the two positions, joining the 2 points, right? So how to determine this? Okay, we are aware of this, that using Pythagoras law we can find it out. That we will talk about this later. So this is called basically position vector. And if it is a vector, there is a notation, way of expressing it as vector is, this. You are giving that crown. Treat differently, as if this is a king. Consider it. Yes. So now vectors have, you understood that vectors have what? Specific direction. To mention the direction, they put a crown on it. Just this arrowhead. Arrowhead is required. To treat it differently, you put that arrowhead. Right? Now you need to treat all the vectors differently. Okay, in this particular chapter, we will talk about this, how these type of quantities, position vector, displacement vector, velocity vector, force is a vector, linear momentum is a vector, right? These things are treated differently. So treating differently, first step is put the arrowhead. Okay, now this is represented as this mathematically. R cap, R is a position vector. Position vector R is represented as 3i. Now this was x coordinate, right? X coordinate plus 3i plus 4j. That means x coordinate is 3, y coordinate is 4. Now if you wish to find out the magnitude of this position vector, that means you are simply willing to express what is the shortest distance, not the direction, not the direction. This is the direction from reference point. We'll talk about this. This OP, this can be considered as the length of the vector, right? OP is length of the vector, and is the magnitude from this reference point. What is that displacement, right? What is that magnitude? No, how far you are from this? How far you are from this? Okay. So magnitude of position vector is what? It is simple, no? See, this is 3, this is 4. What is this? Pythagoras theorem. Just think of it. At this moment, we need to just do this thing. Okay? 3 square plus 4 square, that is going to be 5. Okay? If 3 and 4 coordinates we have taken in terms of meters, then it would be meter. If we have taken it in terms of kilometers, it would be kilometer. So I'm just putting it, whatever unit you will put, this unit. So this is just the magnitude. There is a sense of direction also as a whole. So this is the basic idea behind, the position vector. Position vector. In a plane, how the position of a particle is defined. One thing. Second thing, once we know this, second thing that we require is how the change can be expressed. Change in position vector. Change in position vector will give us the displacement, right? Then we will talk about displacement vector, right? This is the basic stuff. Now, quickly, if we wish to recap the things, there is a sense of direction expressed along x-axis is I cap. I told you, differently you require to treat them differently. It's not only you need to say that, okay, 3 kilometers. No, 3 kilometers along what? Along x-axis. 4 kilometers along what? Y-axis. So different treatment. So these are the special guards, right? These will come along, magnitude and direction, right? Similarly here, but this is magnitude and this is direction. This is also magnitude and this is direction. This represents y-axis, the I represents x-axis. That is so simple. Okay? In the next session, we will talk about the displacement vector and we will talk about other stuff. What is vector, how to define a vector properly, and then we will start with vector addition. First we will talk about the type of vectors and then we will talk about the addition of vectors. So in the next lecture we will talk about mostly about the vectors. What is vector and what are the different types of vectors. Okay, so till now whatever you have done, you enjoy this thing. Okay, and this is very interesting thing coming up in the next session. Do proper revision, do proper learning, and as I told you, visualize. When you will visualize things, it becomes so easy for you to understand, easy for you to apply things, right? And then in real sense you will start enjoying physics. All the best.